Hello friends, in today's lecture we will study a interrelationship between the parameters. Okay, so in your syllabus interconnections, interrelationship we have seen interconnections of two-port network. Okay, so in your syllabus you are having two interconnection. There one is a cascade connection and another is a parallel connection. Okay, so I will try to derive the interrelationship for particular parameter, then we can see it. You can solve the example. Now cascade connection first. Cascade connection. In cascade connection what we do, we are having a two-port network. Okay, we take another network. How it will benefit for solving we will see later. Okay, we will do a series connection between them. Okay, so this is V1, this is V2. For another network this is V1, this is V2. I1, I2, this is I1. Now as this is a V1, we will call it as V1 dash, this is V2, we will call it as V2 dash, this is I1, so we will call it as I1 dash, and this is I2, so we will call it as a I2 dash. Okay, now V1 for this particular network N1, N2. For N1 I can say V1 I1 is, we will see it for ABCD parameter A1, B1, C1, D1. It will be applicable for all other parameters also, but just to check for particular parameter I will considering ABCD. You can consider Z parameter also. It will be exactly similar. V1 I1 in terms of V2 I2, right? Sorry, V2 minus I2. V2 minus I2. This is ABCD parameter for network N1. Okay, what for network N2? For network N2, for this network V1 dash I1 dash A2 B2 C2 D2. V1 dash I1 dash in term of V2 dash minus I2 dash. Okay, now one twist is, check it, V1 dash is nothing but V2. I can say V1 dash is nothing but V2 and I1 dash is nothing but minus I2 and I1 dash is nothing but minus I2. See here, V2 is nothing but V1 dash and minus I2 is nothing but I1 dash. Am I right? So for this first particular part I can write it like this: V1 I1 equal to A1 B1 C1 D1 of V2 minus I2. But V2 minus I2 is nothing but see here, V1 dash I1 dash, V1 dash I1 dash means this part I can put at this particular thing. So A2 B2 C2 D2 and it is V2 dash minus I2 dash. Okay, so for this whole thing I will replace it with A, B, C, D. V1 I1 for two network connected in a cascade, I can say V1 I1 is nothing. V1 I1 is equal to ABCD V2 dash minus I2 dash. Okay, and ABCD is nothing but multiplication of both parameters. So one particular way you are having is, if you are having two particular network, find ABCD for this, find ABCD for this, and then multiply, and you will get directly ABCD for common network. Okay, or else what you can do, if it is identical, then find out ABCD parameter of for one network, and if it is two networks are identical, then you can multiply with itself to get final network. Okay, this is for a cascade connection. Now see for a, let's see for a parallel connection. In parallel connection, this is a network. Okay, I'm having another network. Now input is common, parallel connection, no? Similarly, output is common. This is V1, this is V2. V1, V2 same for both the network. This is I1, which is distributed as I1 dash, I1 double dash. Here this is I2, which is distributed as I2 dash and I2 double dash. This is N1, this is N2, I can say. Okay, so how to solve for this particular thing? So let's do it for y parameter. So for first network, I will write down y parameter as I1 dash I2 dash is y11 dash y12 dash y21 dash y22 dash of V1 V2. Okay, similarly for network N2, I can write it as a I1 double dash I2 double dash is equal to y11 double dash y12 double dash y21 double dash y22 double dash of V1 V2. Okay, so this is what I have written. Now you can see for combined network, I1 equal to I1 dash plus I1 double dash, I2 equal to I2 dash plus I2 double dash. So can I write it like this? See, if I want I1 and I2, I can say I1 is nothing but I1 dash plus I1 double dash, I2 is nothing but I2 dash plus I2, can you see it? I2 double dash, I1 dash plus I1 double dash, I2 dash plus I2 double dash, means ultimately addition of all these parameters also. So it becomes like this: y11 dash plus y11 double dash, y12 dash plus y12 double dash, y21 dash plus y21 double dash, y22 dash plus y22 double dash into V1 V2. Okay, so we can call this as a y11, this as a y12, this as a y21, this as a y22. Are you getting? So this is how we can solve for a parallel connection. Okay, keep it in mind. So if two networks are in a parallel or which looks like a parallel, we can find out y11 y parameter, any parameter, one parameter for one network, similarly same parameter for another network, then you can simply add it to get the final parameter. Okay, now let's solve one example for a cascade connection and one example for the parallel connection. Okay, so already we have seen network, so I am taking a simple example now. Now we are given with a network like this. See, one, two, here also two, I1, I2, V1, V2, and the given question is two identical sections of the network shown in this figure are connected in a cascade. Means this is a one network, another identical network is there in same fashion, and that two networks are connected in a cascade, and we need to find out its transmission parameter. Okay, so let's start. First we'll do transmission, no, and it is connected in a cascade. Means if you remember, A, B, C, D is nothing but A1, B1, C1, D1 multiply by A2, B2, C2 and D2. Am I right? So let's first, two networks are identical, so we'll find out one parameter one network set multiply with same to get final. Okay, so apply KVL I3. So in first loop, when I apply, I will get V1 equal to 3I1 minus I3. In second loop, I will get V2 equal to 2I2 plus 2I3. In third loop, I will rearrange for I3, and which is nothing but 1 by 5 I1 minus 2 by 5 I2. Now put this I3 in equation 1 and 2. Okay. So when we put it in a equation 1, we will get V1 equal to 14 by 5 I1 plus 2 by 5 I2. Okay. We have replaced I3 with this equation. Okay. Similarly, when we put, here I can say put 3 in 1. Okay. When we put 3 in 2, what we get? V2 equal to 2I2 plus 2, instead I3 I will write 1 by 5 I1 minus 2 by 5 I2, right? So this is nothing but 2 by 5 I1 plus 6 by 5 I2. Okay, V2 equal to. Now let's rearrange this equation to look it like a ABCD parameter. So when I rearrange it will look like I1 equal to 5 by 2 V2 minus 3 I2. This is 4. This is 5. Now I got one equation, I1 in terms of V1, I1 in terms of V2, I2. Okay, so I1 in terms of V2, I2. I got ABCD parameter. Put it in this equation, so that we will get V1 in terms of V1, I1 in terms of V2, I2, V2 and I2. So I will have to replace that I1. Put 5 in 4. So V1 equal to 14 by 5. Instead I1 I will write 5 by 2. V2 minus 3 I2 plus 2 by 5 I2. Okay. When you solve it, you will get V1 equal to 7 V2 minus 8 I2. Okay. So A1, B1, C1, D1 is nothing but A1 is 5 by 7. A1 is 7. B1 is minus 8. C1 is 5 by 2. So which I can write 2.5, and D is minus means plus 2 plus 3. Okay. And how to find out ABCD? Now two same networks are connected in a cascade. Two same networks are connected in cascade means multiplication of these with same will get you ABCD. So 7 minus 8, 2.5 plus 3 into same 7 minus 8, 2.5 plus 3. This is A2, B2, C2, D2. Okay, so when you multiply, you will get final parameter as 69, 7 into 7, 80, 7 into 7 plus this thing, first row, first column, likewise, 25 and 29. This is the final parameter A, B, C, D for two cascade network. Though you look here one network, actually there are two cascade network. If another network is not identical, then what you will have to do? First find out ABCD parameter for this network, then find out ABCD parameters for that another network, and then multiply that two networks. Okay, then this will not, here two networks are identical, hence these two matrices are same. Okay, if are not identical, then it will be different. Okay, now we will see one example for parallel connection. Let me take one example from your book. Okay, we have to find out the Y parameter. Network given is like this: 2 ohm, 1 ohm, 0.5 ohm, 0.5 ohm, 0.5 ohm, 2 ohm. Okay, yes, now you can understand the complexity of the network. This is how network is complex, and to solve it with normal parameter equations, it becomes very tedious. So in that case, we take a help of, now see, one common current I1, okay, got divided in I1 dash, I2, I1 double dash. Here I2 I2 dash, I2 double dash. Okay, and voltage V1 and V2. Now instead these two networks, I can write down a one network. I can take it as a two different network. One network, first network with this parameters C 2, 1, 0.5, 2, 1, 0.5, I1 dash, I2 dash, and V1 voltage will be same, V1, V2. Okay, this is node 1, this is node 2. Node 1, why? Because there is no resistance, otherwise this is node 3. Okay, now simply apply KCL at this node and you will get I1 dash equal to 3 by 2 V1 minus 1 by 2. Okay, 1 by 2 V2 solve. Okay, now similarly apply KCL at this network, this node, I2 dash equal to V2 by 0.5 plus V2 minus V1 by 2, right? Here also it is actually V1 minus V2 by 2. I have written final equation. So when you solve, you will get I2 dash equal to minus 1 by 2 V1 plus 5 by 2 V2. 2 first. Okay. Now these are Y parameters. Y11 dash, Y12 dash, Y21 dash, Y22 dash. So 3 by 2 minus 1 by 2 minus 1 by 2 and plus 5 by 2. Okay. Now see, two networks are not identical. So we will have to solve for another network. Okay. So another network is like this. Zero 0.5, 2 ohm. Okay. Now this is I1 double dash, this is I2 double dash, this is V1, this is V2. Okay. So we'll apply KCL at this single node. It is nothing but I1 double dash plus I2 double dash equal to V3 by 2. Okay. What is I1 double dash? I1 double dash is nothing but V1 minus V3 upon this is V3. Because both sides there is a resistance. V1 minus V3 by 0.5, which is nothing but 2V1 minus 2V3. This is I1 double dash. Okay. What is I2 double dash? I2 double dash equal to means this thing, V2 minus V3 upon 0.5. V2 minus V3 upon 0.5. When you solve it, you will get 2 V2 minus 2 V3. Okay. Now we can put this I1 dash and I2 dash here, and you get equation as a this is 1, this is 2. Put in A. So 2V1, this one, minus 2V3 means I1 dash. Now I2 dash 2V2 minus 2V3 equal to V3 by 2 means 0.5 V3. When you solve it, you will get V3 as V3 equal to 4 by 9 V1 plus 4 by 9 V2. Okay. Now put this V3 in first and second, and we will get as a I1 double dash. I am writing directly equation 10 by 9 V1 minus 8 by 9 V2, and I2 double dash as minus 8 by 9 V1 plus 10 by 9 V2. You can solve it. It is very easy. Okay. So now I have got I1 and I2. From this I can find out means I have got the parameters, that is Y11 double dash is 10 by 9, Y12 double dash is 8 by 9, minus 8 by 9, Y21 double dash is a minus 8 by 9, Y22 double dash is a 10 by 9. Okay. So Y11 double dash, Y12 double dash, Y21 double dash, Y22 double dash is nothing but 10 by 9 minus 8 by 9 minus 8 by 9 and 10 by 9. Okay. So now we are having Y11 single dash and double dash both. So is it parallel connection? No. So what is formula? Y11, Y12, Y21, Y22. This is nothing but addition of Y11 dash plus Y12 double dash, Y21 dash plus Y21 double dash, Y12 y21 dash plus y21 double dash, y22 dash plus y22 double dash, right? So simply add it. 3 by 2 plus 10 by 9, 10 by 9. 3 by 2 is a y11 dash, okay? Minus 1 by 2 plus, plus is there, but due to minus 2 become minus 8 by 9. Similarly, minus 1 by 2 minus 8 by 9, and 5 by 2 plus 10 by 9. So you will get y parameters as 47 by 18 minus 25 by 18 minus 25 by 18 and 65 by 80. This is for a parallel connection. Okay, now you can solve any network which you seem is a two networks are connected in a parallel. Now you should have that vision. Okay, then only you can solve the means you can find it out whether it is connected in a cascade or whether it is connected in a parallel, and then you can solve it. Okay, so with this we have completed your two-port network chapter. Thank you.